Hi, we are from Group 7 and in this video, we will explain about the Ltspice simulation of transformer with file name of 20 kVA 20,000 for 800T 60Hz. For the objective is first is to determine the impedance characteristic of a given transformer. Second is to determine the voltage regulation of a given transformer with a specific load. Third is to determine efficiency for a given transformer for a specific load.
Hi, I'm Salehen. I will brief about methodology section. Before we head to declination of open circuit and short circuit value, first we must determine peak value. From the given question, the RMS value for the transformer is 480 volt over set 3 and we get 277.13 volt. Next, if we want to simulate the given transformer in Ltspice, we need P peak voltage value instead of RMS value. To determine V peak value, we will determine the value by multiply VRMS with set 2 and we will get 391.47 volt. Next, to determine whether the value of V peak is correct or not, we will compare it with the origin value from the given transformer to the V peak value that we already recalculated. From the given transformer, the ratio from primary and secondary is 41.67 and from the V peak value that already calculated, the ratio between primary and secondary after we test by probe in Ltspice is 41.65 with difference just only 0.048%. So from the ratio comparison, the V peak value can be used to determine open circuit and short circuit value. Next, to determine open circuit value, we must set the resistance load to 100 giga to imitate open circuit condition. Then supply voltage and current value after we run simulation is 391.47 volt and 769.76 microampere. Next, to determine open circuit power, we must determine theta value first. To determine theta value, from the volt graph, record the time value from the x-axis when the value of the voltage is 0. Same as current, record the time value from the x-axis when the value of the current is 0 ampere. From there, we will get 66.74 millisecond from the volt graph and 69.53 millisecond from the current graph. After getting the times, we will calculate the value of theta by using formula 2 pi multiplied with delta t, and from the answer, we will use it to get power value by multiplying the voltage of the open circuit current and cosine of the theta. From the calculation, the open circuit power value is 0.1494 watt.
The methodology of short circuit test to determine the voltage short circuit and current short circuit is to set resistor to 1P refer to yellow circle and get the result for voltage at peak value is 390.32 volt, while current short circuit at peak value is 327.42 milliampere. Next, to find power based on theta and calculation for power same as power at open circuit test, the result is 0A value at current graph, record time value at x-axis is 86.81 millisecond, and 0 voltage value at volt graph, record time value at x-axis is 83.36 millisecond.
Discussion, we are going to discuss about calculation and how we obtain objectives based on the Ltspice simulation. So, our first objective are to determine the impedance characteristics of a given transformer. At open circuit, we can get the value of YEX, RC and XM. The value of YEX is 1.966 times 10 to the power of negative 6 with angle negative 1.052. And the value of RC is 508724.63. Value of SM 27704.668.24 ohm. At short circuit test, we are going to find three values, which is ZER, REQ and XER. The value of ZER we got 1192.108 with angle 1.3 degree. The value of REQ we got 1191.801 ohm, and SER we got 27.045 ohm. Hence, to find impedance, we are going to identify the value of REQ and SER. So, based on previous calculation, the value of REQ we get 0.6864 ohm, and value of SER are 0.01558 ohm. Then our impedance is SEQ equal to 0.6864 plus 0.01558 ohm. So our next objective is to determine the voltage regulation of a given transformer for a specific load. Before we are going to calculate the value of voltage regulation, we need to identify the value of IS, Q, which is angle, and BP. So from the given value, we can get the value of IS, which is 41.67, value of Q 25.842 degree, and value of BP 505.6275 with angle 1.479 degree. So we are equal to 5.3391%.
Next is to determine the efficiency for a given transformers. We need to calculate the value of Pout, PCU, and Pcore. To find the Pout, we use the formula Vs Is cos Q, and we get the value of Pout is 18001.44 watt. Next is find the value of copper losses using formula Is square Reqs, and we can get the value of copper losses is 1191.857 watt. And the last one is Pcore, which is core losses. Calculate it using the formula V prime P square over RC, and we can get the final value of core losses is 0.5025 watt. After we get the three value of P, which is Pout, PCU, and Pcore, finally we can calculate the value of efficiency using the formula X equal to Pout over Pout plus PCU plus Pcore multiplied by 100%. And the value of efficiency, we can get the 93.787%.
For phasor diagram part, we need to identify the value of I2 times R2, I2 times X2, I1 times R1, I1 times X1, value of E1, E2, V1, and V2. From this slide, we are going to calculate the value of I2 R2, I2 X2, I1 R1. So the value of I2 R2 are 28.61 with angle 25.842 degree. Value of I2 X2 are 0.649 with angle 115.847 degree. Next, the value of I1 times R1, we get 2.07 times 10 to the power of 6 with angle 25.842 degree. For this slide, we calculate the value of I1 times X1, V2, and V1. I1 times X1 equal to 46.97 times 10 to the power of 3 with angle 115.842 degree. So for V2, we are going to use this formula. Then we get 366.237 with angle negative 2.04 degree. For V1, we are using this formula. Then we got 2.09 times 10 to the power of 6 with angle 26.937 degree. So after we get all the value, then we are going to draw our phasor diagram. The according to their magnitude and their degree or their angle.
For the conclusion, all of the objectives are achieved. From the experiment, we can see that the impedance of the transformers is 0.6864 plus 0.01558 ohm. Furthermore, the voltage regulation of the transformers is 5.3391%. And the last one is the efficiency of the transformers is 93.787%.